Thank you, Michael. And I should say I'm very, very happy to be here to see the kind of extraordinary work in the fine-grained kind of research that is happening now. I mean, for example, the prototypes that Rory and his team just showed in which delicately addressable, movable components together with sensor feedback allows us to choreograph with incredible precision and fluency. I mean, the sense of opening up a new language speaks, I think, with tremendous optimism, justified optimism, about the coming decade of very directly and precisely engaged work for architecture. It bodes very, very well. I'm tremendously heartened by the works that have been presented here. I'm here with the dear colleague, Dr. Rachel Armstrong, and Rachel has agreed to share this talk with me. And so I hope that you have a little energy. We'll go a little bit longer than the 40 minutes planned, not too much longer. But so the session is structured as a presentation and then a response. And I'm going to be speaking using an idea about prototyping that's rooted from psychology, rooted in the term extendency. Extendency is a delicious word. It comes from Lacan, the slightly after mid-century psychologist who was looking at the sense that amidst our own consciousness, we also have the sense of an enclosing world, of the other, the realm of alterity, and that space might have its own kind of presence and perhaps has an anatomy that could be traversed and could be encountered, and perhaps we could locate ourselves not simply in proudly bounded, individual, clear containers with names, but rather in that expanded field. The inversion of intimacy then, in the term extendency, might engender in turn a sense of creating a resonant, rather fragile, pulling kind of world. Perhaps that world is one that's already familiar. We were told in beautiful terms yesterday about the second law of thermodynamics and the sense of energy flows, of pulling and pushing, and of how heat flows into cold. And it raises the idea that instead of holding on to things and making things as durable and pure and clear as possible, perhaps there could be a sense of the expanded milieu, a matrix, an enriched kind of field, as a destination for architecture, in which things might be valued not so much by their durability, but rather by their radical potential for their involvement, for their enrichment, for their capacity to engender fertility. I hope I can justify some of those words by showing you quite specifically some projects. And I'll just race through a couple of examples to set the scene, and then I'll try and set things up with some craft. The work that I've been doing with my collaborators in the studio is founded on a kind of an intimacy and a touch, an individual experience of rather delicate materials. And it tends to be invested in layers now, which uses digital fabrication, prototyping materials in order to make quite delicate resonant responses, which tend to be actuated, worked through with kinetics and sensors, in order to make rather turbulent, trembling responses that ripple out as expanded physiologies, sharing a space with individual viewers. The work starts in rather quiet ways by setting out ghost-like structures, rather crystalline forms that have tried to void out material use, and instead set out skeins and networks, tending to use diagrids and textile forms in order to make very, very lightweight resonant scaffolds. Shooting that full of distributed computation and sensor networks allows the environments to be tracked. And that results in a reaching out, in a sense, not so much of something doing our bidding, where we push a button and we get an immediate response, but rather small increments, rather gentle muscular movements and registers of our own presence, rippling back to us and starting to import a sense of sharing, perhaps a kind of a breathing, perhaps an ambient kind of architecture. The work can become turbulent. Here's an image from Sydney where there's just a bit of a lightning storm happening when the sensors are wound up too tight and before we've asked it to calm down. Alongside that kind of active response, there's been quite a lot of work in material tuning itself. We're looking right now at a new layer of fabric that's being done in collaboration with a really lovely fashion designer, in which there's an attempt to construct deeply fissured, pore-like, foam-like environments which have a kind of an osmotic pull to them, that is, encouraging gentle convective loops of air to go through rather leaky valves in order to make a kind of expanded physiology that ripples around bodies. And this produces quite a robust kind of veil around bodies that seems to have a lot of potential. We're quite excited about the potential of this work. Alongside that material investment, we're also working increasingly with fluid and viscous materials, seeking a kind of a saturation, a kind of reticulum around spaces that imparts an active metabolism and a fertility, a saturated kind of space, akin perhaps to soil as a design space for architecture. And that produces this kind of grotto-like form, which I hope does not move only into a kind of this stasis of being clogged and overly saturated, but which I hope instead has the kind of turbulence in which there is clutching and cuts and stasis as well as active exchanges in order to produce the kind of fertile churn that might keep things moving and renewing. I'll try and set up this discussion then in 4 parts. I want to make some comments about place and placement, the sense of moving and gesturing towards the world and making a contribution as designers. I'll point very briefly to some enabling crafts and technologies that perhaps point towards a sensitive relationship, and then move quite quickly through a range of projects that try to demonstrate some of these strategies before ending on some notes about culture, about a cultural tradition that might anchor this way of working, moving backwards away from humanism, moving perhaps towards a more material and body-based involvement in the world. And then Rachel and I hope, can have a dialogue speaking about near-living systems as a way of launching this forward. I come from Canada, and I love the north, where I can stand really quite securely on the ice-scoured ground. That sense of the ground being absolutely immovable and reliable is one of the most delicious senses of being in a country like that. But my body doesn't say that I'm reliable right now, or that the world is certain. The sense of a trembling kind of meniscus to the earth is one perhaps that's shared. The sense of uncertainty of a surface of the earth which is in transition. And it raises the question then of how to respond, of how an architecture might move beyond the previous Vitruvian values which tried to take advantage of a certain world and produce that kind of emplacement, infirmitas, and move into a state of fertility and renewal. Perhaps it might be tempting to try to work with optimums, such as the ones that Plato has told us about. When we think about using things well and minimizing our footprint, it's almost inevitable to think about a kind of reduction and a closure which tries to wind things up into the most perfect way of using things imaginable. And that way of thinking, which is so very necessary in our practice, perhaps brings us back to the Platonic series of reductive forms, perhaps inevitably to the kind of optimum of a sphere. I mean, after all, if we think about perhaps working ethically or perhaps working practically about the most radically efficient way we can work of all in using materials and enclosing our world as architects, then perhaps we can think of the maximum possible enclosing territory in the minimum possible envelope. After all, envelopes are expensive. Territory is important to enclose, which gives us absolutely mechanically, inevitably, a sphere, a reduced kind of interaction with the world. And yet, along with that kind of optimum, that kind of beautiful transcendent perfection that Platonic form languages, minimalism, gives us, it would seem, I think, that we also are given, perhaps unintendedly, a machine for resisting interaction with the world. After all, there can be no less interaction, arithmetically, than the form of a sphere with the surroundings. It's the minimum possible kind of contact surface, the most defensive form. That's what makes it so incredibly effective as a form for ballistics, for example. I want to appreciate and work with such optimisms. I mean, I think that if we think about the kind of form of a raindrop, for example, then we might think of it in a kind of exquisite balance of form finding, in which we are told that this is a necessary kind of energy retention, a beautiful way of working, of winding up a kind of design. And yet, I do wonder about the effect of working with this kind of reduction, the sense of closing, the sense of minimizing, the sense of stripping away the kind of necessary excess and extensions and fertility that might foster innovation. And it's very strange to me, then, when I think about perfect forms, and I think about perhaps what nature is telling me, why I wouldn't think, along with a raindrop, of a snowflake. I mean, why do I automatically think that this is a frilly, excessive, wasteful thing, a trivial thing? Why wouldn't I think that this kind of form is its own kind of optimum? I mean, perhaps it could be expressed as an optimum. I mean, if we think about a need for things to shed heat, to cool, or to seek interaction with the world, then the kind of diffusive form language that a snowflake teaches us about might offer its own kind of exquisite optimum. I mean, because after all, this is the inverse of a raindrop, in which a material, rather than priorizing enclosed territory, rather than priorizing the minimum boundary and the maximum defensiveness, instead seeks to have the most radical involvement with the perimeter, with the world possible. Another kind of optimum, then, the minimum possible enclosure, the maximum possible involvement, most delicious kind of efflorescence of involvement and exchange. And if we think about perhaps the form language that makes batteries efficient, or perhaps the mitochondria in our own body, then we can readily, I think of these kind of form languages of radical exfoliation as being extremely important and really tremendously interesting kind of form language to pursue as well. And so that sense of diffusive form as being a complement to reductive form is one that might inform, I hope, a kind of involvement in the world, in which replacing the sense of the stripped, certain horizon that precedes us, it might be possible to work with a soil-like condition of generating fertility and generating a kind of efflorescent involvement in material terms through a kind of an expanded presence and involvement in the stewardship. Some technical crafts present themselves really in tremendously encouraging ways, and we've seen so many examples of those in the beautiful presentations that have been shared in the last couple of days. Michelle Addington is a particularly encouraging example, a wonderful Yale engineer who has worked so meticulously to see how energy exchanges around the body and around buildings can be addressed in meticulous octaves of thermodynamic exchange, exposing that the milieu around each of our body is a convective plume with energy that can be harvested. This sense that air, rather than being a void, is an actively addressable medium for designers. That sense, and perhaps this would be echoed by Bob Shields' presentation on scanning, can be expanded into a sense of working with space as well and addressing those same kind of energies as a kind of milieu. I mean, a wonderful example of remote sensing and of accessing the magnetic shield of the Earth itself provides a sense that rather than space being a neutral, open field, instead it can be seen as something which is intensely populated with layers of material and energies, which increasingly can be turned into a design space with the precise crafts that are now available to us. I love the sense that the aurora borealis is not some kind of vague halo, but rather has a very direct kind of anatomy, tracing out the fault lines in the Earth's crust, and having quite precise in energy exchanges in it, which can be addressed and then worked with. This sense at that scale also extends into the cell itself, and Donald Ingber's wonderful example, the cancer researcher, now the head of the Weiss Institute on the east coast of the USA, gives us another kind of anatomy, which again offers a kind of design space for architects. That is, the kind of fluid anatomies here seen in the cytoplasm, in which myosin and actin, two proteins, wrap up into microtubules, the viscous kind of compressive struts of the myosin, the actin stretching into tensile frameworks, and those two things working together into this kind of tensegrity grid, a three-dimensional lattice, which structures the viscous medium and therefore becomes addressable as a design space, rather than the kind of vague jelly-like homogeneous realms that we might have thought of when we were young science students. I love the sense of participation then in liquids and gases and air as a very tangible and structured medium, increasingly available. The artificial life researcher Rachel Armstrong, with Martin Hansick and Lee Cronin and other members of the new movement working with prototype cells, have been exposing ways that designers can work with skin-making mechanisms and carbon-fixing mechanisms, and a whole range of processes that have a kind of a delicacy and an enabling fertility in them. I mean, tremendous kind of renewal by working dynamically with materials. Increasingly moving then from the Vitruvian static world of design into the sense that design can be a kind of metabolism. And perhaps then, if we wrap some of those processes, that is, the sensing and the chemical exchanges, and the rather subtle structuring of Ingber's world together, then perhaps we could be encouraged by the organizations of those systems into productive metabolisms that can impart fertility, such as the example of the organization of the lymphatic system in our own bodies. I love the sense that the lymph system is this somehow shambling, rather leaky network, brambles of valves, which rather than being driven by their own power and their own intelligence, rather ride on top of muscular movements and pump lymph through the system, processing toxins and renewing our bodies. But with a remarkably kind of forgiving, informal organization, very different from the crystalline, reductive, Platonic world of a spine and one single system which must be perfect. I love the kind of forgiveness of this kind of organization. In the work of the studio, the kind of ideas that I've been sharing have moved through several phases in the last few years, and they've moved through a layer of geotextiles, that is, scaffolds that expand the surface of the Earth and serve as a kind of a protection and growth layer that might impart new fundaments, kind of Earth surface machines, moving into a sense of trying to work quite directly with fertility, trying to make kind of soil fields. Geometry has been quite important to this work, looking not so much at purely stochastic or random structures or free structures or perhaps the inverse of crystalline structures, but rather intermediate states of quasi-periodic structures in which things start to stutter and convulse and move and generate new possibilities while still drawing on quite precise formations. Those systems have moved into a model of trying to make diffusive metabolisms. And more recently, we're trying to work in a much more intimate ways, rooting this kind of architecture directly in an expanded physiology of the body for participation. I'll show a few examples from this, just moving through that kind of sequence that I described. the expansions of the soil, the geotextiles from quite early years, were ones where there was a tremendous pleasure in making a kind of terrain. For example, this twig lattice from a haystack vale, which is made so very efficiently by clearing a farmer's field of alder as a favor and then using that material in this triaxial weave that was used as a kind of a sheltering network for organic growth over several years, with little things nesting in it and catching turf and building up a new kind of resilience. In endothelium in Los Angeles, we used that same kind of structure but invested it with organic power, simple vinegar cells with copper and aluminum electrodes, making tiny, pathetically little amounts of charge in each cell, just 5 milliamps. By changing those together in series by the dozen and using capacitors, we could harvest little bits of power and then use those to blip out tiny amounts that would power LED lights as lures, and also cell phone vibrators that were chained to robotic feet that, like porcupine quills, burrowed into the earth. And so you can imagine this entire layer silently, rather gently, pathetically burrowing into the earth, seeking its own kind of fundament over the couple of months of the installation as it died. More recently, we've been working quite symphonically in the sense of layering those systems together, working with lightweight scaffolds and a chemical metabolism and distributed computation, such as the layered, quite immersive ground that we made for the Canadian Pavilion in the Venice Biennale. And that work built up, rather patiently, a series of ripples through individual increments that tried to create a kind of ambience, very gently chained together small increments using air actuation and shape memory alloy actuation, elements which have a gentle, small amount of response each, but by being chained together by the hundreds and sometimes the thousands, quite formidable crowd-like, swarm-like responses do occur. And those elements then are generated in large assemblies that build up strata and layers. A hyperbolic meshwork above that makes it quite a robust structural system of peaks and valleys of doubly curved surfaces with force shedding. That is, when you push at one element, it sheds its forces into its neighbors and allows a kind of resilient strength. Hovering filters which pass convective plumes through them, shot through with metabolic chemistry, very simple protocells processing materials and generating new skins. And the kind of bladders and traps and glands that you see, the kind of soil-like elements here, generate their own kind of presence. Now, on one hand, the computation that's used here is very, very simple. That is, individual microprocessors chained together, producing the kind of actions that might be familiar from a chorus of crickets or a swarm of insects, perhaps, or perhaps the kind of opening and closing of polyps within a coral reef. We're starting to work with shift registers, which is a way of addressing many more masses of actuators and sensors in choruses, while still using very modest microprocessing power, marching through data sets in order to ramp up the kind of collective intelligence that can be addressed. And we're quite heartened by that new generation. Alongside the computational controls, we concentrate quite closely on making individual components and staying very close to material performance, the kind of snap-fit joint that has been with us for the last 3 or 4 years with this kind of chevron that clips together to make the dual of a tetrahedron that can then be multiplied, has a kind of resilience in it that reduces the need for fastening and allows composite arrays. You can see the kind of hyperbolic meshworks that are produced from that chevron series here in the unclothed mode, and some of the kind of derivative forms, that is columnar structures and tapers, and then the ability to address and clothe these environments as scaffolds. Alongside or clothing that kind of structural scaffold then is a soil-like layer of a reticulum of many chambers that have fluids and salts that pull and push and generate a kind of blooming humidity around them, And then there are active systems which impart convective plumes through it and house more deeply invested protocell environments, which then generate skin cells and operations such as the one that you see here, which Rachel and I did a couple of years ago. This is a Traub cell formation in which a delicate copper felt is blooming out, working in osmosis, continually pumped around this copper sulfate crystal. And these kind of systems then, layered together and chained, produce kind of feedback loops that perhaps produce the operation of creating soil. In the prototype upstairs that we did in collaboration with Chantal and Michael and incredible students from Nottingham, who's here that worked on it? Can you please all raise your hand and be recognized? Shout out to all of you, you're incredible. We share a special bond of blisters and little bits of blood. And in this version, we've moved into metal in much more robust structures, and also a protocell layer, which is a carbon capture system using the Leduc cell process, which has some very interesting performance. It has a tremendous encouragement, not in terms of its efficiency yet, but in the capturing of a potential, because the kind of the powerless osmosis that comes from organizing filters in order to pump air through itself serves as a kind of a machine for generating a breathing and a renewing that seems very encouraging. Those two layers are not fully integrated right now, and so I hope it can be seen as a raw structure, which is more speaking about potential rather than an optimum. But it produces this kind of diffuse weather-like sense of composition, which is judged by density and potency rather than by clarity. In the Voltage series, a new collaboration, this is very raw work, and so I just wanted to share where the work is going. We've been winding up the individual components in order to qualify them for cloaking a body in the world of haute couture, which generates not so much a day-to-day sense of what we wear and what our stable relationships are, but rather the sense of potential and of occasion in which there might be that possibility of where we could go and who we could be and the kind of space that we might be able to inhabit. Here you can see a rather kind of a heartening, robust silicone meshwork that swarms around the body in quite a muscular way. And we're very heartened by this work because of the chance to work choreographically. Here you can see just the structure of the diagrid mesh, where individual impact-resistant acrylic elements are chained together with small silicone tubes, in order to make a diagrid corrugated mesh with very lovely kind of visceral, viscous performance. I'm going to try to speak just quite briefly about a cultural tradition, and then conclude, and then perhaps Rachel and I can have a dialogue. I've complained about a Platonic world, a reductive world in which envelopes are closed and optimum and clear, and I'm trying to make an argument for a form language of diffusion, of involvement. This kind of photograph or painting, Piero della Francesca's Flagellation of Christ, painted in the mid-1500s, is usually celebrated as an incredible move forward into humanism, out of the primitive medieval world. And on one hand, it's impossible not to celebrate the kind of architectural achievement of this kind of vision. And perhaps it would be one that's continuous with the kind of beautiful public forums that Mies van der Rohe offers us in the Neue Staatsgalerie of Berlin, or the Toronto Dominion Centre in Toronto, or the Seagram Centre, in which a stripped stage produces the maximum kind of freedom and beautiful kind of space for democracy, in which human interchange is the absolute priority, justice and sensitivity between us as a species. And we can see that kind of sensibility happening here in Florence in this image. not so much in the religious scene, which is the obligation, but rather in the contemporary Florentines that are conversing on this miraculously gridded stage, the achievement of a perspectival grid that renders the plane of the ground as something coherent, a design space, and then clears it and renders it solid and prioritizes the kind of intimate touch between people. I care about you. I want to honor you. I want to negotiate my space with you. The kind of lateral social axis, which is such an extraordinary kind of achievement of humanism from this period and moving forward into our own period. And why would I complain about justice or care or this kind of beautiful generosity? Only because of the preoccupation with the lateral axis at the expense of a different kind of axis, of perhaps an existential one. It seems to me that the earth is stripped here and rendered inert. And perhaps there might be a sense of moving backwards into an involvement with the surface of the earth that I hope would enrich this scene rather than sterilizes it for human domain only. Moving very slightly backward then, perhaps we could celebrate Leonardo's very early Annunciation, before he became really sophisticated and socially oriented. This is a beautiful painting, I think, painted very early in his career, when he was preoccupied with the surfaces, the strata of the natural world. And if we think of this kind of stage of being so very carefully constructed, looking at the layers of soil and garden material and plant material, which is laid up as a kind of an essay of how the surface of the earth might be constructed, moving out into the aerial form and moving even further out into the dissolving sense of the upper foliage and the air. You see a kind of a beautiful kind of material involvement. Moving backwards then into a sense of even greater involvement, perhaps the kind of surface of the earth might wrap around us. And I love this image by Neri de Bici of the mandorla, the kind of maternal halo that might produce its own kind of fundament. I love the way this Neo-Byzantine painting is constructed out of flames of light and out of very direct patterning that makes for a kind of material, direct involvement in the surface of the earth, a kind of construction of the earth that might offer a kind of design space. A step backwards again into the Ibel Gospels, painted around Reims in the 800s, has a kind of a trembling, a kind of tremendous ambivalence about the surface of flesh and the world, in which every single brushstroke becomes a kind of a touch and an intimacy. Such a very different agenda then in this kind of work than the agenda of purifying and rendering one, and rendering hard and clear and durable and firm and eternal. This kind of ambivalence, I think, has a tremendously interesting and valuable example, a set of languages for us. Just to anchor this, I want to just share a couple of terms from medieval theory, and then I'll wrap up by looking at Fra Angelico, who was following the same tradition as the master of the Ibel Gospels that I was just sharing. This is moving again into the late 1400s. But in this work, this is a fragment from an Annunciation, the same kind of religious Christian works that I've been sharing before. We see an investigation of the formation of life, the formation of fundamental elements, and far from the kind of body-hating transcendental world that yearns only for heaven, we see a remarkable kind of investment in paint, in turbulence, in disfigured things. In fact, the kind of turbulent ground that this figure stands on is very directly and deliberately not touched by the kind of human will that would say that geometry rules the world, that meter rules the world. Instead, there's a deliberate kind of limiting of human will and a release, dissimilitudo, disfiguration. These are medieval terms that Albertus Magnus, the teacher of Thomas Aquinas, who wrote this tremendous canon of what the Christian world needed to hold in the Summa Theologica. This man was speaking about not only a mineral involvement, of full-blooded involvement in nature. But he was also speaking about a kind of consciousness which deliberately lost control and deliberately allowed you to be released and pulled and pushed and bewildered. Those terms then, disfiguration and dissemblance and dissimilitudo, are ones that make a particular kind of practice in medieval contemplation, which is very directly informing this kind of contemplative painter. And you can see it very explicitly then in some of his manipulation of paint, such as this work in rendering stone, the underlying marbles in the convent of San Marco in Florence, where you see a remarkable kind of release. Now these are not accidents to spatter paint and to drag across a surface. This is a master figuration. Fra Angelico has tremendous amount of control in being able to delineate precisely. The choice then of releasing and scattering makes for a really extraordinary kind of sensibility. And my hope then is by showing those kind of works, it might invite a kind of investment in a form language which might search for resonance and involvement, valuing a kind of a turbulence and a churn that might foster a kind of renewal. I'll just summarize that by speaking about those paintings as a kind of a veil and an architecture around a body, and certainly a familiar one then, a Platonic one, would be the ascription of a halo around a divine figure, making the most perfect form possible, and speaking about a kind of a polarized world then. But the kind of body-based involvement, veils of material that I've been showing, offer a different kind of involvement, I hope, a release and a kind of an interchange. And perhaps that generates this sense of fertility that's invested in the projects that I've been sharing. And certainly it speaks about a kind of potential in any event. So I'll wrap up. I've complained about raindrops, and I've admired snowflakes, in spite of them being quite frilly. And I've talked about Michelle Addington and the vision of a design space with subtle phenomena and energy exchanges, which is available as a direct practice. Some partial components, spinning them together into composite systems, produce, I hope, some rather sensitive configurations, invested with a new kind of metabolism which opens out a possibility of working in the future, and perhaps occasionally working symphonically so that it can produce quite a robust, involving kind of space, rooted in an intimacy and a touch. So I hope that those are a kind of contribution to the practice of prototyping. Thank you.
I just want to respond to Philip's delicious language and poetry about diffusive forms and gestures towards life, essentially, in design and engineering. And I guess I just want to spend a few minutes talking about beyond the machine. Is there something that comes after the machine? Because in order to imagine our world, in order to design and engineer it, we seem to have one very strong metaphor, one that predominates, and I guess in some ways it liberates and contains practice at the same time. And the thing about machines is that they're imagined in a very particular way. Machines are a series of Cartesian objects that are geometrically described, arranged in hierarchies, and are fundamentally inert. In other words, the way that we imagine the world is at equilibrium. And if we're going to make gestures towards life, as Erwin Schrödinger said in 1948, life is a structure or a system that evades the decay towards equilibrium. So if we are to build things, whether they are very small objects or very large ones, then we need to think about how we design, engineer, manipulate, orchestrate systems that are far from equilibrium. And essentially raising the question, if we do this, are we actually talking about a new technological system that will replace the machine and perhaps one that gives us another set of gestures towards different kinds of prototypes with different ways of making. So this is a picture, a photograph that was taken on one of the steps around the canal side in Venice. And as you can see, there's a kind of natural computing that goes on here. The computing itself is not separated by a mind and a manufacturing process, but in fact the information and physicality of the system are intimately wound together. This is the accretion actions of bacteria, algae, and marine wildlife. And essentially, the practice of natural computing is one that I would like to consider right now as being an alternative to thinking in terms of machines. And the term itself came from Alan Turing's fascination for the computational powers of nature. In fact, David Deutsch it suggests that actually only the physical world can compute. And we have spent at least half a century thinking about computation as being something that's actually a very virtual experience, one that deals with the intangible aspects of reality. So I mean, is this just poiesis? Is this just gestures towards imagining things in a different way? Well, partly yes, because these technologies are not mature, but they do exist. And they exist as what I describe as operating systems in research laboratories around the world. This is Martin Hanzuk's work again, with smart droplets, or what they're now calling soft robots. Programmable substances that essentially work from the innate chemical forces, molecular forces of the jostling that goes on at the realm between water and oil. This is Andy Adomatsky's work at the University of South West England, who's been working for many years with slime mould computing. We're getting slime moulds to make decisions about their environment, and not just trying to program the thing itself, but actually now understanding the relationship between the system and its environment. So whilst Cartesian programming is very inside-driven, the agent itself does all the work. Within natural computing, there's a huge amount of work that is done by the environment. And this is Lee Cronin's work with artificial chemical cells, or iChells, at the University of Glasgow. And these are being imagined as dynamic little batteries that can grow very friendly, frondy hairs from them, a bit like Philip's diffusive structures. So essentially, can we conceive of a language that enables us to escape the ideology, the I guess preconceived notions of what is possible when we design and make with machines? And so I'm going to attempt to express such a language. I'm using the dynamic droplet system that I work with at Martin Hanzuk's laboratory. So when we think of natural computing, the first thing that you'll notice is that the components are not manufactured. They're self-assembled. And this is a droplet of alkali, which is the pale area, being added to a field of olive oil, which is the dark area. And the droplet spreads out and breaks up into millimetre scale droplets. And when it does so, we can no longer think of these droplets as objects. They're agents. They have a force and a potency of their own, which is completely independent of human intent. Not only that these droplets do not have a hierarchy. They're not arranged in a linear system. They become an interacting group of transient, reversible relationships between each other. And we can think of this as being an assemblage. Deleuze and Guattari's notion of transient bodies that form these temporary connections and associations with each other. We can also see that this system now in an agentized assemblage has qualities that start to give this platform a unique character. This is no longer the certain geometries of machines, but actually becomes a flexible, robust, sensitive, rather diffusive and effusive kind of technology that is uniquely sensitive to its environment. And although you may think of these droplets actually as being something that you wouldn't really want to work with because they seem to be so chaotic, so uncertain, they are actually quite predictable. But their predictability is within limits. The picture that Philip showed right at the beginning of his talk of the man standing in an environment which is actually wrapped in uncertainty is exactly the kind of parameters that this system deals with. It deals with action, but within limits. So I describe it really more like making a cake than making a stack of Lego bricks. That you know that if you put flour and eggs and sugar and butter into a cake mix and you whip it up and you put it in the oven and you play with the temperature and you put other things in there and you take it out, you know it's going to come somewhere between a dirty black biscuit, which is my end of the cooking spectrum, to a fantastic gâteau, which is the kind that my grandmother makes. But it never kind of walks out as a sausage roll or an umbrella. There's a certain amount of predictability to that system. And that's exactly the kind of variation that we can start to learn to orchestrate and deal with as a kind of technology. But one last description of this platform, although it comes from a place where certainty isn't the mode, and there is this degree of predictability to the system, there is an exception, and we've probably all heard this term used in terms of environmental changes, and that is when the system reaches tipping points. And you're about to see a tipping point reached here. So all of these droplets, there's a home team quietly building a set of microstructures there in the middle, and it's being joined by the away team. And all of those were made under exactly the same conditions. And when they start to combine, they're forming a new assemblage, new interactions, new relationships, new forms of communication. And then you will see a systemic change in the way that these agents exist. They start to change their shape and their form of action simultaneously. And really, we still don't know how these tipping points are reached and how indeed they work. And this obviously is a cause for further study. But this is again, a potential disadvantage of this kind of system, or it is a potential opportunity to work with systems that can invoke unpredictability, can invoke novelty when you think that a situation is certain, and certainly when we're dealing with environmental change and we're thinking about evolution itself, to actually create novelty, this radical novelty that underpins the material world, is one of those things that a form of natural computing could possess. But of course, this isn't really a technology until we can actually find ways of engaging with this technological platform. So we know that it exists within a probabilistic realm rather than a deterministic one. We know that its information and its modes of production are actually entangled, they're not separate. But how do we work with this? We can do this by changing the internal and external conditions of the system. And that's very different to machines which are not responsive to external circumstances. So here I've changed the internal conditions of this system. I've added a mineral so that this particular droplet can make little crystals in the presence of carbon dioxide. And in this particular system, I've actually added alcohol to the oil field, which the droplets absolutely love, and they swarm towards it like a stampede, upon which they become very quickly slowed down and rather still. So we can actually add chemoattractants to these systems and actually start to manipulate their progress. And when Philip first invited me to have a go at using some chemistry in order to, I guess, evoke a different kind of technology, my first reaction was to try and create a huge field of these droplets. And these droplets exist about a millimetre in diameter. But really, it wasn't until I tried slowing down their metabolisms that I could actually get a system that I could work with, which the smaller droplets there are about a few millimetres in scale, but the larger ones really are at a centimetre scale. And once we start to get droplets that are a centimetre scale, they become tangible, they become visible to an audience very clearly rather than milky streaks across a Petri dish. And we can actually start to play around with the chemistry of these dimensions so that the computational processes themselves become, extremely tangible, extremely present. And of course, scaling up again. So, there was a question about scale a bit earlier about prototyping. The idea that assemblages, if you know Deleuze and Guattari's work, they become entangled with other systems. So assemblages become entangled within other assemblages, so that the idea of the Hylozoic ground starts to talk about the entanglement of two technological systems, one of which is roughly mechanical, even with its effusive behaviours, and the other one being a kind of natural computing, working with this non-equilibrium state. Of course, we push our machines into non-equilibrium states when we supply huge amounts of energy. But the natural computing itself possesses this, this gift of energy, that it absorbs energy from its environment and shoots it out. So Ilya Prigogine was the guy who got the Nobel Prize for this kind of diffusive structure. And so essentially, within the Hylozoic ground installation, these chemical technologies existed as a kind of, smart droplet system that could smell and taste its environment. It could smell and taste the carbon dioxide in the system, which was breathed out by gallery visitors. And I think of it as being a smell and taste system because it's responding to dissolved chemistry in a very similar way that our own nervous systems do. But this was just one species of dynamic chemistries within the system. This is a Liesegang ring plates. So these were precipitation diffusion reactions. Essentially, the crystals become liquid at certain points within the gel. And this was another system that we didn't quite use, which is a Traub cell, which is essentially a growing membrane that produces little pockets of membrane that we started to entangle then with carbohydrates like alginate. So essentially, really, the working with Philip, allowed us to explore the possibility of a technology that allows us to work at non-equilibrium states that gestures towards the design of life or lifelike systems. So,